Hello everyone, I am Avinash. Today we are going to discuss a few questions on the research paper, a survey on platform for big data analytics by Dilpreet Singh and Chandan Reddy. If I were to choose a platform where the criterion is amount of time, I would choose GPU due to the following reasons. GPUs are optimized for speed. GPU with its thousands of processing cores, around 2500 cores with the processing power of 10,000 teraflops, is well suited for time-constrained applications. It has a memory bandwidth I'm sorry, it has a high memory bandwidth, as GPU has its own DDR4 memory and it is way faster than the DDR3. It is used in many machine learning algorithms. With the help of GPU miner library, and experimental results have also proved that they are very fast in computation and delivers output in minimum time. Apart from this, FPGA is also known for its speed, but this is not my choice because it has a limited number of applications. Hadoop peer-to-peer network scales out to a large number of machines, but takes more time to be delivered, and hence they are also not my choice. If I were to choose a platform, if the criterion is number of iterations, I would choose GPU as my platform. Even though HPC cluster, multi-core CPUs, FPGA are all suitable for iterative algorithms, I would choose GPU because of the following unique and appealing features it has. The problem of data being written and read from the disk is eliminated, as GPU has memory caches, which are faster in memory access. Data is processed as threads, where each processor handles multiple threads and all the operations occur in parallel. This is also practically proved using the K-means algorithm. Finally, GPUs are faster than multi-core CPUs. MPI uses peer-to-peer, which makes it run out of the race, and FPGAs have limited number of applications. Even MPI can also be used for iterative algorithms, as there is no need to read the same data again and again. Like for an MPI, we cannot. There is no. It's not required to read the data again and again. But due to its fault intolerance nature, it is not preferred as my choice. Hence, GPU is the best choice for this platform. Coming to fault tolerance. Fault tolerance is nothing but it is the ability of the system to perform properly in the case of any of its components got failure. Virtual clusters are the major fault-tolerant systems. They use MapReduce or Spark, which have efficient built-in fault-tolerant mechanisms such as having several backups of data that is being processed, so that even if one node fails, the other copy is used. The high-performance computing cluster, multi-core CPU, GPU, FPGA doesn't have any fault-tolerant mechanisms as such with them, but they are very rarely prone to hardware failures, which, in this context, making them a fault-tolerant system, but not complete due to the occasional failures they can face. The peer-to-peer are fault-intolerant due to the two reasons. They don't have any built-in fault-tolerant mechanism, and they use commodity machines, which are highly prone to hardware failures. Scalability. Scalability is defined as the ability of a system to cope up with the increased demands in data processing, which is done by adding more hardware, scaling out, or like upgrading the existing thing, scaling up to meet the requirements. In the case of virtual clusters and peer-to-peer networks, they are easily scalable by adding more machines and can be scaled out to any extent needed. The high-performance computing clusters are a bit difficult to scale up because once a high-performance cluster having thousands of cores is deployed, it is very expensive to scale them up. The same goes with FPGA, as once FPGA is developed and deployed, it is very expensive to scale them up. And GPU is not that good at scalability, as there is a limit on number of GPUs a machine can have, and by adding more machines, it creates a bottleneck. Now let us see the advantages and disadvantages of each kind of platform. Peer-to-peer. The advantages are like, in terms of the data size, peer-to-peer networks can handle even petabytes of data and can theoretically scale out to unlimited number of nodes. The disadvantages of the peer-to-peer system are like the network communication is very slow, as it has unmanaged and complex network scheme, making it very inefficient to aggregate the results over a single node. It is weak in performing iterative algorithms. To combine the results from different nodes after every iteration presents a significant challenge due to the complex network structure. Fault intolerant. It's like, uh, and this is the most crucial disadvantage because there is, if there is one machine breakdown, and the entire process has to be stopped, and they don't have any built-in fault tolerance mechanism with them, which is the most crucial disadvantage of the peer-to-peer. And coming to the virtual clusters using MapReduce, they are fault tolerant as they have a built-in fault-tolerant mechanisms. They are scalable. They can be scaled out to any extent needed based on the demand, which is the most crucial advantage of this kind of platform. But it takes time to handle the large amount of data, and they are not suitable for iterative algorithms, as the data has to be written and read after every iteration and making the disk I/O a bottleneck, which is the most crucial disadvantage of this kind of platform. And the virtual clusters using Spark. It has the ability to perform in-memory computations, and the the most the crucial advantage of this kind of platform is that it allows data to be cached in the memory, eliminating the disk overhead limitation of Hadoop. And the disadvantage is like efficient in parallel processing. This one is efficient in parallel processing, but it is not typically used for handling real-time data processing tasks because they are slow in data input-output rate between the nodes, and they do not contain powerful optimized hardware. And coming to the like vertical scaling thing, the high performance computing cluster. The platform is said to be fault tolerant because of high-end hardware that it is using. Hardware failures are extremely rare, and the disadvantage is that it's like expensive due to the high-end software that it is using. The multi-core CPUs. A task can be handled parallelly in between multiple cores. And the disadvantage of this one is like it uses DDR3 memory, which is slower. And the most crucial disadvantage of this one is the number of nodes in the CPU are still in double digit, where the processing power is of 10 gigaflops. Coming to the graphic processing units, the advantage of this system is like this platform is the GPU is extremely fast when the data is needed to be transferred to or from a peripheral device because they have high throughput memory. It has DDR5 memory, which is much faster than DDR3. GPU with its thousands of processing cores and high memory bandwidth is well suited for real-time data processing, which is like the crucial advantage of the platform. Coming to the disadvantages of GPU, there are limited amount of software that can support the GPUs and limited number of algorithms that are portable to GPUs. The primary drawback is the limited amount of memory that it contains. With a maximum of 12 GB memory per GPU as of current generation, it is not suitable to handle terabyte scale of data and making it difficult to scale, which makes a crucial disadvantage of this kind of platform. Field Programmable Gate Arrays (FPGA). FPGA shows highly optimized speed and is faster compared to other platforms for certain applications such as network security, where it is used as a hardware firewall, which is much faster in scanning the large amount of network data compared to the software firewall. The drawbacks: it has few disadvantages such as limited to certain number of applications, and it has limited amount of memory. The crucial disadvantage is like coding has to be done using the hardware descriptive language (HDL) with less knowledge on the hardware. It increases the algorithm development cost, and it is more complex to handle. Thank you for listening to my video, and if you have further queries, you can please refer to a survey on platforms for Bigdata Analytics by Dilpreet Singh and Chandan Kiri.